Hi everyone, welcome back to Algebra 2. Today we're going to be working on section 5.3, which is all about graphing radical functions. And so we're going to be graphing cube root functions and square root functions. But the main idea that we want to stick to is we want to stick to this main idea that would be how can you use what you know about transformations in order to graph the function of radical functions. Because it's not necessarily important that you can graph all of these by hand, but it is important that you can have a picture in your head about what the radical function looks like and about which direction it is shifted up, down, left, or right, and then be able to just imagine a rough kind of draft or a rough graph in your head. Because if you can do that with transformations, then that skill is going to be helpful later on. So when we talk about transformations, we're talking about knowing your shifts horizontally, left and right. Let me just switch pins. So you'll need to be thinking about your horizontal shifts, vertical shifts, stretches, compressions, all of those things. But first, before you can shift a function around, left, right, up, or down, you have to have a good idea of the parent function. So you have a picture right here. You'll want to add these into your notes, the parent square root function and the parent cube root function. So let's talk about the parent square root function first. The parent square root function is the most basic square root function, and this equation is y equals the square root of x. And so every square root function should have this shape, kind of like a half a parabola turned on its side, if you can kind of picture that. It'll have this shape. It might be moved up, it might be moved down, moved left, shifted to the right, might be stretched, might be compressed. But every single square root function will have this shape. And so I have a table of x and y values to explain why these points are the way that they are. So let's start with the positive values. If x was 9, according to the equation, y would be the square root of 9, which is 3. If x was 4, y would be the square root of 4, which is 2. If x was 1, y would be the square root of 1, and so on. But if you look at the imaginary numbers, like -9, y would have to be the square root of -9, and the square root of -9 would be imaginary. And the graph, the coordinate plane, only graphs real numbers. So since we can't see imaginary numbers graphed on the real coordinate plane, we're only going to be graphing real numbers. So none of the negatives will stop. So this is why the square root function stops, the parent square root function stops at 0, 0. So let's fill out the domain and range, because you are going to be asked several questions about domain and range. So the domain and range of the parent function, it starts at 0, 0. It touches 0, 0. So it goes from x equals 0 until the largest x value. This graph is going to continue forever and ever to the right. So the largest x value, there's not really one, so we'll call it infinity. The range, the lowest y value is at the origin. So from y equals 0 until, and this graph, it is increasing and it continues to increase. Although it does it slowly, it's still going to increase forever and ever. So our y values will also approach infinity. So domain and range, both 0 to infinity on the parent function. Now, if I shift this function up, down, left, right, the domain and range are going to be affected. Now let's look at the parent cube root function. The equation for the parent cube root function is y equals the cubed root of x, and its graph looks like this. Now this graph has two sides. It goes to the right and it also goes to the left, and that is because for our negative numbers, if x was -64, oh, I forgot a negative right there, the square root of -64 is -4. Those are real numbers. So the domain for our cube function goes all the way from negative infinity on the left side to positive infinity on the right side. And then the range goes from, although it does seem like it does seem like the graph does not go very low on the y-axis. To the left, it's still decreasing and going further and further down in the down direction. So eventually, that graph will get to be really, really low value. So the range will be negative infinity. And then even though, yes, it does seem to kind of grow slowly, still going to grow infinitely. So the range will be negative infinity to positive infinity. And you'll also want to add this. A radical function is a function of this form, f of x equals a times some kind of root, whether that root be a square root or a cubed root. You'll have a number out front times the root of x minus h plus k. So notice when it's in this form, because it's going to come in, this is going to come up later. Notice that when it's under the radical, there's no coefficient in front of the x. So in order for us to be able to see our transformations, there must be no coefficient in front of the x. So if I want to see if there is a vertical stretch, a horizontal translation, or vertical translation, then I need to make sure that my function is written so that there is no coefficient in front of the x. And I will show you how to do that in a little bit. So our a value, the number out in front, is going to determine the vertical compression. If a is greater than 1, it's going to be a vertical stretch. If a is a number between 0 and 1, then we'll have a vertical compression. The h is our horizontal translation. And notice I have a minus h in the equation. So if you look in the equation, you see minus h. That means you're going to go to the right. That function will be shifted to the right from the parent function. If you look in the equation and you see a plus h, and notice the plus h is under the radical. So if you see adding a number under the radical, that's your horizontal translation. So if you see a plus h, the parent function shifts to the left. The k is a number that is added outside the radical. And that determines the vertical translation. So if you look at the equation and you see a plus, a number outside of the radical, that'll tell you that that parent function shifts up. And then if you see a negative k, that will tell you that the function shifts down. And then sometimes you'll also need to determine if there is a reflection. And that has to deal with, you'll find that by looking at the a value. If you see a negative a, that is a reflection across the x-axis. So pause the video, make sure you get all of these written down because we are going to need them quite a bit today. So then on example 1, I've got to clear the screen. On example 1, we are asked to graph the following function and then identify the domain and range. So let me put the parent function on here. So I've graphed the parent function, y equals the square root of x. I chose the square root function because my function f of x equals the square root of x minus 5. So since I have a square root in part A, I should use the parent square root function. So I'm going to graph it, but I'm going to use the parent function to graph this function. I see that I'm subtracting 5 inside under the radical. So that means it's going to shift the parent function to the right. 5 units, and that's the only transformation that's happening. So every single point, the point that was at 0, 0 on the parent, goes to the right 5 units. So 1, 2, 3, 4, 5, and I'll put a dot right at 5, 0. The point at 1, 1 gets shifted to the right 1, 2, 3, 4, 5 units. So I'll put 1 here at 6, 1. The point that was at 4, 2 is going to go to the right 5 units to be at 9, 2. And then it looks like I'm off the graph. So then I will draw that. So, and I'll label it f of x equals the square root of x minus 5. Then I'm asked, what are the domain and range of the function, and is the function increasing or decreasing? So the function they're referring to is the f of x, my new function in red that I graphed. So let's see the domain. Well, the domain of the parent function is 0 to infinity because the graph starts at 0, 0. But for f, the graph starts at 5. So its domain is from x equals 5 until infinity. The range, now I'm looking at y values. The graph of f starts at 5, 0. So the x value is 5, but the y value for the range where it starts is 0. So the range is from 0, and then the graph continues to increase after that. Then there's a question, is the function increasing or decreasing? Well, because after 5, 0, the y values continue to get bigger, f of x is always increasing. Then part B has me to graph g of x equals the cubed root of x plus 1. So that tells me that the parent function, I'll write the parent function in black. The parent function is the cubed root of x, so let me draw the parent function on here. So now that the parent function y equals cubed root of x is drawn on there, we can think about the g of x function, which has a plus 1 under the radical. So that means I'm going to shift everything to the left 1 unit. So everything is shifted to the left 1 unit. So the point that was at 0, 0 goes left 1. The point that was at 1, 1 goes left 1. And the point that was at -1, -1 also goes left 1. So now my graph looks like the one in blue. It's kind of hard to see, so I'm going to see if I can erase the parent function underneath. There we go. So just so I can see g of x a little bit better. All right, so then ask for what is the domain and range of g of x? Well, for domain and range of g of x, even though this function got shifted to the left, the domain still goes from -infinity to infinity because the graph extends forever and ever to the left direction and forever and ever to the right. The range is also going to remain -infinity to infinity because the graph always extends forever and ever in the negative direction, and then it extends forever and ever in the positive direction. Then asked, is the function increasing or decreasing? Well, if I trace the function from the left to the right, I notice my pencil is increasing, is getting higher and higher and higher. So I'll say my function is an increasing function. Example 2 is some exercises in identifying the transformations. So it gives me the graph G, and then it tells me the parent function is f, the square root of x. And I'll scroll down so you can see the pictures a little bit. And then it just asks me to identify the transformations, and then a question about domain and range. So let's talk about how we got from the function f to g. All right, so whenever you're identifying transformations, if there are multiple transformations, you're going to follow the order of operations. Now, when I say follow the order of operations, I mean find the x, and then from the x, think about what happened to the x following the order of operations. So with the x, the thing that would have happened next would be you would do what's inside the parentheses. Now, the radical acts like parentheses because it's a grouping symbol. So the first thing that happens would be to follow what's in the grouping symbol would be that -1. So if you see the -1 under the radical, that means you're going to translate everything to the right 1 unit. And then that 1/2 on the outside is a vertical compression by a factor of 1/2. And then the -3 is a shift down 3 units. Now the domain and range are going to change. Domain would change to be from 0 to infinity. Domain is now going to be from 1 to infinity. And the range was 0 to infinity, but now it's going to be -3 to infinity. And you might even see some patterns or some matches, like how the 1 is right here and the -3. And then if you look for those numbers in the equation, you might see some similarities there.